actually also you're one of our speakers last year and this year. So let's quickly hear about your talk about pipeline architectures. This sounds very interesting. What can one expect?
That's interesting thing. Yes, we all know pipes in Linux, Unix shell. So you know how to connect one output to the input. We also know that we have this ranges library, and recently I started some consulting to the companies. So I was teaching ranges, and I was preparing, as I mentioned, the second volume of the book. So I was looking for some materials to explain some mechanisms. And I wanted to know how this overloaded OR bit OR operator, this pipe operator is implemented, and how does it work. So I was looking for some presentations, and so I found some materials presented by other people about overloading custom OR operator and doing some processing in the functional style. So if you're programming something and you see that your program is going to be arranged in some kind of a pipe, so you call function from a function or function after function. So this is the good idea to have a more general pipeline architecture. So I followed up this idea, and I implemented this overloaded operator. And the point was how to process errors in such a pipe. Certainly, you can throw at any point, but this is a rather hard operation. So the good would be to be able to process, let's say, normal objects and sometimes error messages at the same pipe. So you can build a struct or a class to this, but fortunately in C++23 they come with this expected object, which is incredible. You know this stud optional. So stud optional can have an object or doesn't have an object. Well, it is some kind of a pioneer to this stud expected, which can process much more because it can have an object, and any kind of error can be passed with instead if something happens. Even more, stud expected is endowed with so-called monadic operations, which allow themselves. They allow, as I mentioned in this title of this talk, monadic operations. So instead of custom pipe operator, you can use monadics from stud expected and have entire pipeline implemented only thanks to the stud expected API interface. So that's really cool. And the last thing is when I connected everything in the pipes and it was working quite nicely with all these errors. Imagine you can have an error on the way of some processing pipes, and you can even fix the error by another member of this chain. So that's really powerful technique. So I will be talking about this during this presentation. But the last thing is, when I implemented all of this is all serial. So I was thinking, what about if we have some threads or thread pools connected by synchronized queues and also arranged in a pipeline? Yeah. So I implemented also such a thing in, well, let's say, rudimentary, simple way, but to show the main idea. So yeah, I am on my way of finishing this presentation, because I need to fix everything in, let's say, 45 minutes to have some time for questions. So that's not very easy, but I think it can be very fruitful, especially to incorporate this new guide, this tut expected, into your code base, into your code frameworks. That's really something I can recommend. I think that's...
Sounds like an interesting talk, especially
Thanks.
covering like a lot of angles, and so it's going to be in 31 days.
Yeah, but I am on my way.
But I know you got to be done, and then you start the polishing.
Yeah.
So thank you very much, Boguslaw.
Sure, thanks.